Welcome all of you. This is the sixth video on our topic molecular rearrangement and reactive intermediates for the organic synthesis. And so this will be this video cover the week 7 problems on the problem based on the week 7 questions covered in the assignment. So here uh, we'll discuss some of the problem. Most likely will be similar to the assignment questions. And if you have any doubt, please let me know. If you have any doubt regarding any covered which is in the seventh one, so that we'll discuss today. So we'll first collect the your doubt first, and then we'll move towards the session. You can put your doubts in the chat box. So I will move towards the questions. So please interrupt me in between. So if you have any doubt. So this is the first question based on the same topic that we are looking for. So basically, this involve the Grignard reagent and the protection unprotection of these functional group. So particularly here, the carbonyl function group protection and the protection steps are involved. So if you look at the static material, they're given. So we have carbonyl protection. So we can protect the carbonyl in this manner. So if we have such group, so let's say take the example of this aldehyde. So this aldehyde in presence of the dithiol, so this SH, and so this one. So you can protect this to in this form and in this manner. So now if you look at the polarity of this CH bond in this compound, particularly this CH, let's say take one example, and this is the delta positive and this is the delta negative. But in this case, this is if you we can abstract this proton. So here that is delta positive and this one is delta negative. So from this one, let's say if you look at the reaction condition, we have the butyl lithium, that's the base, and the this Grignard, not sorry, this is the bromo compound which has the epoxide. So if you look at the structure, so the first step is the abstraction of the proton. So after abstraction of proton, this is the acyclic proton available. So these are the protons, which are the acyclic protons. So butyl lithium abstract this proton. So on abstraction of this proton, in presence of the butyl lithium at minus 78 degrees Celsius, so it will leads to the formation of this moiety, this intermediate. This is the negatively charged intermediate, so which attacks on the bromo compound in the SN2 fashion, and this negative charge attack on this bromo compound, so this Br negative get removed, and we get a product. So we get in this manner the product like this. So this will be the proton will be the remain same. So how many? One, two, and three. Four carbons are there. One, two, three. Four carbons with the epoxide in place. So this is the product that we get after this reaction. And further, in presence of HgCl2, so this HgCl2 basically deprotection. So if you add HgCl2 here, HgCl2, it will give the our keto compound back. So in this case, here on in presence of the HgCl2, so this protecting groups get removed and we get the our keto compound back. So that's the So this compound we get back. So which has the 1, 2, 3, 4 carbons with the epoxide, 1, 2, 3, 4 carbon with the epoxide, and this keto group with the attached solution. So we get the A product as a major product in this case. So HgCl2, role of HgCl2, you need to understand, two keto, this HC bond. So this SC bond cleavage takes place in presence of the HgCl2. So any doubt in this question? Here you can see the mechanism as I have already discussed. So you can note from here. And one thing I just maybe also highlighted, this attack takes place in the SN2 fashion. So if any question come with the stereochemistry, at that time you need to keep in mind, uh, let's say if you just induce the stereochemistry in similar examples. So examples with the chiral center, let's say. So if you have some example which has the chiral center, so at that time, so let's say we have this group. This is the bulkier group, and nucleophile forms after the butyl reaction of this butyl lithium with this starting material. So which leads to formation of this negatively charged carbon anion, and then further it attacks on the SN2 fashion on the carbon on the group we have. So let's take example of uh, this compound. So this is the bromo, which has the, so let's check this the case. So we have such epoxide, right? And here, see the, let's say this is the CH3, and here there is the hydrogen. So in this case, uh, if the reaction of this takes place, then what will be the product? So that product will have the chiral center, the inverted in the configuration takes place in that case. So this is the CH3, it will be in the plane as it is, as in the starting material. Then further, this chiral center will be remain unaffected. Further, this again center, and in this case, at the center here, the center, the bromo, the stereochemistry of bromo will be the inverted, and here the hydrogens will be on this not bromo. The stereochemistry of hydrogen is initially it was the dotted. Now it will be on the wedge bond. So this will be the hydrogen, and here the backside attack takes place. This CH, right? Now here this will be the carbon which has the two sulfur groups attached. Just right. So this will be the stereochemistry of this center. So hydrogen will be there, and upon deprotection on reaction with the HgCl2, it will be CHO on the dotted line. So I will just draw correctly because the bond is not with the oxygen, it will with the hydrogen. So this is the product form in this case. So this SN2 attack that you need to keep in mind. So attack takes place by the SN2 fashion on this substrate, and this is the reason for the SN2 the inversion in the compression in the product. And again here the deproduction step uh, gives the our carbonyl compound back. So in this case, it was the aldehyde initially. So we get the aldehyde as in the product. So other options, you can directly neglect the other options. So in this case, they have shown something else. So you can neglect other options here. 1, 2, 3, 4. Here they have increased one carbon chain. And in this case, again, they have also opened the epoxide. So that's not the case in this type of. reaction. So hope you understand this question. So we take the next question on this. So this question basically involve the attack of the secondary butyl lithium. So that's again the strong base. So this is the secondary butyl lithium, and it abstracts the proton. So in this case, there will be ortholithiation reactions, right? And the reaction of the secondary butyl lithium takes place. We have the starting metal which has the three multiple hydrogens. So there are four hydrogens available in the our starting, and obviously there are other hydrogens which are basically inert towards this secondary butyl lithium. So in this case, what happens? So this is the our starting. So I'll just expand the structure so it will be easy for your understanding. So basically, in terms of the secondary butyl lithium, there will be only the hydrogens which are ortho to some sort of chelating groups involved. They will be get abstracted. So in this case, there is the one hydrogen. So I will label it as a, and this is the B hydrogen, and there are obviously C and the D hydrogen. So, but if you look at the reactivity, so the C and D hydrogen is likely to be inert toward the secondary butyl lithium, and we have the now hydrogen A and the hydrogen B. So if you just distinguish between these two hydrogens, so there will be this hydrogen is slightly sterically hindered. So if you look at this bulkiness of this methyl group and obviously this entire group, so there are two group adjacent, but this methyl group is inactive towards the earth lithiation. Only it only creates the bulkiness. So preferably, so this hydrogen B is getting abstracted by the secondary butyl lithium, and we get a species intermediate. So this will be the negatively charged now, and lithium. So here there is the O, CH2, O, CH3. So once this intermediate is formed, it react with the, we have the CO2. So basically, this is the electrophile. Now this negatively charged attack on the carbonyl carbon. So it gives the formation of carbonate. O negative. So this will gets open up, and there is a CH3, right? And further upon hydrolysis or the workup, acidic workup, preferably H3O plus. So this O negative abstract the proton from the aqueous media. It gives the formation of C double bond O H, and the remaining group will be the same, right? So here, what happens? So the first one is the preferential abstraction of the proton. So we have distinguished there are four hydrogens. So why this HB is preferentially get abstracted in this reaction condition, and further once this nucleophile is formed with the butyl lithium, so this oxygen at the ortho position which stabilize this negatively charged lithiated complex, and which further attack on the carbonyl center of this electrophile. We have the carbon dioxide as a electrophile source of electrophile, so it gives the carbonate anion, and upon acidic workup, so it gives the formation of the product. So among these options, so option A is the incorrect option, as you can see. uh, I'll just wait a minute. right? Yeah. So it gives the formation of our final product. In this case, uh, this option they have abstract the proton which is at the HC, so which is obviously the inactive. So that's a wrong option. This again is wrong because here there is no any option to form this product. We need to form here anion. So with the lithium, so that's not possible. Again, this one is the, yeah, this is the correct product that we got, and the last one is the option D. So which has they have given the correct product by the hydrogen. But if you look at the steric hindrance at the HA and HB position, so HB is less sterically hindered. So the preferentially the secondary butyl lithium, which is again the bulkier, so it will be preferably abstract the HB proton, not HA. So the second bulkiness of the secondary butyl lithium drive this reaction selectively, and we get the HC, sorry, the C as a major product, not D. So here you can look at the detailed clear reaction mechanism. You can note it from here. So I will take the next similar questions. Here we have given this is the third question. The predict major product formed in the following reaction. So you have given a starting material which has the bromo, uh, anisole and the C triple bond N. So we have the diverse range of the functional group in the starting material. So first one is the bromo side, bromo on the phenyl. Second is the methoxy, and this is the C triple bond N, CN cyano. But if you look at you can also see the available options you have given. So all these CN group will be remain same. So we can go by the direction also. It will be unreactive in our reaction. Right. So here we have given isopropyl methyl magnesium bromide. So this is the Grignard reagent, and which has the which is comes from the isopropyl methyl magnesium bromide. So we have given the isopropyl methyl magnesium bromide. So which on reaction with this, so it will give the, so always keep in mind. So whenever you have given the either methyl magnesium bromide or butyl lithium, that type of reagent, it will be preferably react on these uh, aromatic halo compound. So in this case, we have the aromatic bromo compound, and again we have the some stabilizing factor also here. So when this isopropyl magnesium bromide react with this compound, it will give the formation of, so this product, and which further attacks on, we have given the source of electrophile here. So in presence of this bromo compound, uh, this can attacks on the electrophile, so it will give the formation of the product. So here sometime it will looks like some confusing because we have this nitrile group, but it will be not participate in this reaction, and this is the product is formed after the reaction. So this is the similar reaction as seen earlier, so which involve the uh, ortholithiation and followed by the addition of the electrophile. So it gives it forms the carbanion at the benzyl position. So on the phenyl ring, further it attacks on the electrophile. So here the source of electrophile, this is the delta negative and delta positive. So this bond basically the active bond here, and this is the carbocation. This delta positive, this is the delta negative. So this negatively charged form so attacks on the either this way or it can attack on this position on further drive these force, but both will give the similar product. So this is the product. So you can identify from the options given. So this is obviously the wrong option. So you have the option C is the correct option here. And you can also note it from here. So this is the clear mechanism that I have mentioned here. So if you have any doubt, please interrupt me in between so I can solve that one. So you can note from here. Now we'll move toward the similar third question. So this is basically we have given the starting which has the C triple bond N group, and we have given here now the ethyl magnesium bromide in one equivalent, right? So this question is something that I also want to highlight in the previous also, because in this case you can see in this case there will be some different reaction, but in earlier case it was some different the reactivity of this Grignard. So here we have the ethyl magnesium bromide, and which is CH3 CH2 negative MgBr positive. So this is the CH3 magnesium ethyl magnesium bromide. So it attacks on the electrophilic carbon here. So here the nitrile uh, we have the C triple bond C, and there is a triple bond. So this triple bond, again we have the nitrogen. So this triple bond, this is the nitrogen. The carbon is electrophilic. So we get a product in which now we have given particularly one equivalent. So this is the first step we got here in this reaction condition, and upon H3O plus, that is the acidic workup, so we get the formation of so this imine reduction, sorry, upon the workup, so this will give the so this imine bond get obviously the eliminated, and upon hydrolysis it will use the keto. So we get the option B in this case. So you can see the mechanism also here. So this ethyl magnesium bromide attacks on the nitrile C triple bond N. Further, it gives the imine intermediate, which on the workup, it gives the imine followed by it gives the keto. So that's what I have shown. But you may ask the question. So here, why it has attacked on the nitrile C triple bond N? But in earlier question, I have shown why it haven't this isopropyl magnesium bromide haven't attack on the C triple bond N. So here also you can see there is C triple bond N is present. But if you look at the reactivity, this isopropyl magnesium bromide, so this is the negatively charged and this is the MgBr. So this is the nucleophile. So if you look at the nucleophile, so this is the isopropyl group. So that's the bulkier group. The first thing is the bulkiness of the isopropyl. And second one is the reactivity of this phenyl bromide. So this phenyl bromide part is more reactive towards the uh, Grignard than this C triple bond N. So that's drive the attack of this isopropyl magnesium bromide takes place on this bromo part, not on the C triple bond N part. So any doubt here? All right. So we'll move toward the next question, and which is basically on the similar type of, we are seeing the Grignard type of reaction. Uh, so this is the zinc based reaction. So you have given the bromo ester. So this is the ester part. and this is the alpha beta bromo ester, right? So in presence of the zinc, what happens? This ester part, so I will just draw in this fashion. So this is the bromo part, and here it react with the zinc. So we have, if you look at the starting, we have the multiple sites active. So which site preferably react in this condition? So this is the similar Grignard type of addition. So the first, this bromo part, when it react with the zinc, it will be similarly forms a zinc bromide. So which is similar to the that we Grignard prepare the Grignard. So in the preparation of Grignard reagent, we add these, let's say CH3CH2Br plus, let's say we add the magnesium. So up in the dry THF, which is obviously anhydrous, so without any moisture. So it gives the formation of CH3CH2 EMGBr. So that's the Grignard. And in the similar fashion, the zinc can also react. It gives the formation of these zinc ZnBr. In Grignard, we generally use the magnesium, and here they have used the zinc. So once the zinc is formed, so this is the zinc delta positive, and the carbon will be the delta negative, which attacks on the starting that we have given, the starting, which attacks on the carbonyl carbon. It gives the formation of, this is the part from the starting, which and this is the newly formed bond. It gives the intermediate, which is obviously the stabilized by the zinc complex, which further attacks on the carbonyl center. So upon addition of carbon center, it gets cyclized. So this is it forms a 5-member ring, and we get the product. So it will be the similar. So as like the Grignard, the first step is the formation of the CZN complex, and this ZN complex leads to formation of the carbanion on the carbon center, which further attacks on the aldehyde. So that's the second step. And the third step will be the cyclization. So ester group is more susceptible to react such type of cyclization. So which is driving force here to get the cyclic ring. So the option A is the correct option here. So as we have also seen, there is no any bond formation. So all other options are incorrect. The option A is the correct option here. Now, in the same manner, I will take the next question, which is again I have shown earlier also in the probably last video. So we can reduce the reactivity of the Grignard reagent. So if you look at if we have some centers, let's say uh, we have this example, and we want to selectively attacks this, let's say ethyl magnesium bromide on the carbonyl carbon. So we can use ethyl magnesium bromide, and we get the after workup and all. So we get this is the product. But if someone may want to react the ethyl magnesium bromide at this center, so he need to add the copper complex. Someone, can you, Satish Kumar, can you please mute yourself? Right. So we can add the copper salt. So in place of the copper, so this ethyl magnesium bromide can act as the soft nucleophile and we get the formation of. So this ethyl will be add on this position. So this is the newly formed bond and the carbon will be remain as it is. So this is the in this way we can tune the reactivity of this the Grignard reagent. If you want to attack on Grignard on the carbonyl carbon, we can choose the simply ethyl magnesium bromide or the methyl magnesium bromide. But if you want to react in the 1,4 fashion or on the carbon atom, so that time you can add just the copper salt. So it will be act as a soft nucleophile and it will be show the 1,4 addition in this way. So this carbonyl group will be remain unreacted in this reaction. So in the same manner, here also the same question given. So you have given the copper lithium. So as in the same example I have explained, it will be act as a soft nucleophile and it will be preferentially show the addition on the this carbon, which is the adjacent to the carbon group. So the 1,4 addition is dominant here. So I will just draw in the same fashion that I have shown. So this is the starting we have. Now we have the OTBS, which is directing downward. So let's say OTBS directing downward. So better I will draw as it is. So because here stereochemistry also involved. So here, so this is the starting we have. And if you look at this OTBS, so OTBS is directing downward. So it means the downside is sterically hindered. Now we have the CH3 minus, which comes from the CH3 twice. So this CH3 negative, which attacks on the this position because it acts at the soft nucleophile because of the copper. And also here one thing you need to keep in mind, the addition takes place on the top side, not from the bottom, because on the bottom side there is a this OTBS bulkier group present. So we get a product in which the incoming methyl group is directing upward, and this OTBS obviously directing downward, which is as in the starting metal. So here, so we get the option B is the correct option here, and upon obviously upon hydrolysis. So I just now draw in the mechanism. So that will be in the next slide. It will be similar to the last reaction. There will be a so once it attack here, so there will be a shifting of the bond takes place, and here the copper uh, one intermediate is formed. So I will just draw that one also here. So this is the intermediate complex. So this is the first, and on hydrolysis, it gives the formation of this product. Right. So option B is the correct option here. So here the stereochemistry involvement is there. So that you need to keep in mind. And secondly, this in presence of the copper, this the Grignard type nucleophiles acts as a softer nucleophile and it shows the 1,4 addition instead of 1,2 addition or instead of on addition on the carbonyl group. So here, so option B is the correct option. Here you can see the refer the detailed mechanism for clearly written. So you can note down from this one. All right. So we'll take similar some questions, more questions. So these questions are similar to your assignment questions. So another question, which is again, I don't think there is need to explain this in more detail. So here you have given a compound which has the methyl group directing downward, and obviously you have given the Cu copper lithium complex. This copper lithium, obviously this CH3 nucleophile, CH3 negative, So there will be obviously no direct bond. I will just uh, write in this fashion. So this CH3 negatively charged, which attacks on this position on this carbon, which further gives the intermediate like this. And again, I also like to highlight here also the addition obviously takes place on the top side. And further upon hydrolysis, obviously it gives the, so here they haven't mentioned. So upon workup, it gives the keto back, and here there is a methyl. So in this case, it is again although three bond away, but still there is some sort of steric crowding, so which will give the this as a major product. And obviously there will be another product will be the minor one, but that will be you just ask the major product, so you can ignore that one. So this will be the minor product. So the major product is this. So you can write down here. So which is the major product? So option A, right? So option A is the correct option here. This is the same question as shown earlier. There is no any such difference. So you can refer this reaction mechanism and note down this. All right. So here there is the next question, and this question is the same question, but only thing in one, it is a intramolecular fashion. So in this case, if you have this uh, again the same complex, so this Me2 copper lithium. So always keep in mind this whenever you have such either iodo compound, or let's say this is aryl iodide or any alkyl iodide, not only iodide, obviously we can take as a halogens also any X. So whenever you have such bond, so they have a highest reactivity towards these, whether it is methyl magnesium bromide or butyl lithium or Me2Cu, that copper lithium complex. So organocuprate reagent. So they always react faster than other functional group. So if you look at this methyl copper lithium complex, so we can call it as organocuprate. So they generally, this react very quickly with this C I bond now here. So once it react, it forms the negatively charged at this position, and this negatively charged, and it convert into the another copper complex copper. Then this is one species is react, one molecule, let's say, react. So this will form such intermediate complex. So better I will draw on the, so this is the, we have the starting, and here when it react with this copper complex, so it gives the formation of this negatively charged and the copper lithium complex. This is the another methyl, that the part of the reagent. So now this reagent is again, now if you look at the reagent, so this is again a one type of copper reagent, right? The copper complex, or we can say it as a organocuprate. Now this again react with this bond, it gives the formation of, so this is the O negative now here, and this bond will be the remain same, which is on the bottom, upper side, sorry. So I'll just draw that as it is. And we have the side chain, which has, if you look at the number of carbon atoms, so there is one, two, three, four carbon atoms. So I will draw that one. This is the one, two, three, and the four carbon atom, and it attacks here. But keep in mind, the attack of this takes place in the, so here some I just okay, I just missed the one point. So when it react with the reagent, the first attack will be the methyl attack on this position. So the after first attack, the second step is involved. So after this attack, it gives the formation of this O negative complex, and which then react, right? Once this attack takes place, so after that, this negative charge involved here, and this double bond, which attacks on this iodine and gives the formation of 5-membered ring. Not the way that I have shown earlier. So here the double bond will be remain same. The obviously methyl attacks takes place on the uh, top side, sorry, the bottom side, because this group is on the top, and here now it is from the 5-membered ring. So which is again remain the part of this alkyl chain. Right. So the first step, not as I have shown earlier. So that's the not the correct way, but that might be the also possibility in the starting. If you just analyze the reaction, that might be also one of the product. Right. So this is the simple type of reaction. So it is the only the first attack will be the on this position. After the first attack, the O negative form, which further uh, attacks on the iodo compound, gives the formation of the product. So that's the some right. So yes, I can show in the chair compression, that will be clear. So if you have this the same structure in the chair form, so how it will be looks like. So let's say you have this, right. So if you look at here, so the attack takes place on the downside. Why this attack takes place on the downside? So this is the reason. So if you look at the chair form, so in this case, whenever this CH3 CuLi attacks this CH3 negative, attacks on the bottom side, because the top side is completely sterically occupied by this isopropyl group. So that's the reason the addition of this first methyl group takes place on the bottom side. So here this methyl, the new, takes place from the, that's the axial bond, and this was the equatorial one now, which is directing downward. So if you consider the equatorial attack, sorry, the axial attack, so that will be difficult on this one. So by this side, the attack will be not possible because of this steric crowd. And once this product is formed, so there will be a O negatively charge here. This O negative, which is obviously the stabilized by the copper complex, which further, when it comes back, it attacks from this position, this double bond from the alpha position. So there is a one side chain. So that side chain, initially it is in the in the plane, right? So here also it will be in the plane. So there are four carbons. So one, two, three, four, and this is the iodo. This negative charge comes down. Now it attacks on the carbon, and this iodo get eliminated. We get the cyclized product. So that cyclized product will be, there will be a 5-member ring because of this 4 carbon and 1 carbon from the part of ring, and we get the product. So this is the product. So here the methyl is the directing downward. The isopropyl will be the same as in the starting. This carbonyl group will be retained again in the product, and this is the 5-member cyclic ring is getting formed in the product. So option B is the correct option here. So here what they have given only the first step, but the second step also, the parallelly it will takes place once the intermediate one intermediate is formed. So that intermediate further proceed the reaction towards the cyclization, and you can simply neglect the other options. So here only the changing in the stereochemistry that they have shown, but the reaction further, due to the reactivity of the C-I bond, it drives this reactivity further the second step. Right. So you can refer from here also. So we'll take some similar questions based on the cyclization or based on the some Grignard reagent. And right here is the another example, and that again the same that I have shown here. So here the first step is the methyl magnesium bromide, so which attacks on the carbonyl. So I will just draw the remaining part of the molecule as it is. So here, so this will form O negative MgBr, and here the earlier methyl from the starting, and the newly attacked comes from the Grignard. So that will be here. And once this negative charge forms on the O, so which further, here there is a chloro group, so which further drives the SN2 attack, gives the cyclization. So here there is 1, 3, 4, and the 5. This 5-member ring formation takes place. Right. So option D is the correct option here. These are the some confusing whether attack takes place on the carbonyl center or on such center. That's some critical here to understand. So he in this case it methyl magnesium bromide attacks on the carbonyl center. So that's the step you need to keep remember. So you can note the mechanism from here. So the first step, as shown earlier, the attack. So this methyl attacks on this carbonyl center, and once this O negative anion is formed, which further attacks on the CX bond, that is the CCl bond. So the delta positive on the carbon and the delta negative on the oxygen. So it helps to formation of this five-member ring. So always need to keep remember whether there is formation of a possibility to form five-member ring. So that time this sort of different side reactions take place. Generally, it is not happens in the if there is no such five-member ring formation. So if you just look at the some other example, so it doesn't have the such five-member ring accessibility of such. So let's take this example and which has the CS3 MGBR. At that time, the first step will be the same as earlier, the O negative, and there will be a the CH string from the Grignard. And once this form, so there is no, although there is a CCl is present, but that will leads to the formation of four-member ring, and four-member ring uh, not favored, so it will further gives the formation of this product, which involve the chloro will be remain in the same product. Here there was possibility of five bonding formation. That's why the reaction proceed further for the five bonding formation. And earlier case also there was possibility of five bonding via. So in this case particularly, right, this one through this carbon, this five bonding is formation takes place, and that's the driving force for the proceeding further reaction to this molecule. Right. So here, as also I think I have discussed this here phenyl magnesium bromide, but you have added the copper chloride salt. So due to this addition of this copper chloride, this Grignard reagent acts as a soft nucleophile, and the addition of this phenyl magnesium bromide, so which takes place on the 1,4 position, not 1,2. So the phenyl attacks at that position. So we get the formation of, and this is the phenyl. Yeah. So this is the product is getting formed. So the option B is the correct option here. So you can see this is the reaction mechanism, and this is only because of this copper chloride. If there is copper salt is absent, so let's say you don't have such copper salt at that time, the reaction will be like this. So this newly come phenyl from the methyl magnesium bromide, sorry, phenyl magnesium bromide. So in this way, these are the some the problems are only which drive the reactivity, whether it acts on the carbonyl center or the carbon, olefinic carbon, in such alpha beta unsaturated ketone or alpha beta unsaturated aldehyde, the sort of systems. Here also you can see this is the one reaction, and in this reaction, so this zinc in diethyl and which react with the alpha bromo ester. So what is the name of this reaction? So if you remember, this reaction is the which involve the formation of the zinc bromide complex, and which further leads to formation of the enolate. And again on reaction with the keto, so it's similar type of aldol condensation type reaction. So it attacks through the enolate on the keto group. So we have the keto acetone. So right, so this is the keto acetone, and this is the part come from the acetone. So the attack takes place on the carbonyl. So I will better draw this reaction. So go step by step. So you have this reaction, and if you look at the reactivity of this CBr bond, so in presence of zinc or magnesium, it will cleave. The metal insertion steps takes place. Now this is the CH2 negative, and this is the ZnBr, and this negatively charged. Whether you can also stabilize here by this fashion. because OZN complex is more stable than the this CH2. So this O ZNBr and this will form the CH2, the olefin here, and which further react with the any, let's say we have the any keto. So this negatively charged negative and the positive, which by this way. So through this carbon, so it attacks on the carbonyl center and it gives the formation of. So here I will just explain with the example with the phenyl acetone. So sorry, benzophenone. This will be the O negative. The CH3 will be remain same, and this is the CH2 comes from the acetone. Sorry, the earlier part, the ester O ET. So that's the product, and upon hydrolysis, it will be PH OH. This is the methyl, and this will be the part of the our starting ester. So this is the entire part will be the remain same. So that's the part. So this is the part from the ester, and this is part from the keto group. So this similar aldol type reaction takes place here. So in the aldol also you can, if you remember, the abstraction of a proton. So let's say in this case, the abstraction of proton acetone, proton from the, let's say CH2H. So this proton abstraction negative, and further this negative charge attack on the another molecule of this carbonyl compound. So this attack takes place on the carbonyl. It gives the formation of this one. But that in that case, there was a possibility of the uh, removal of the water. So this the so there was active hydrogens. So elimination of water also takes place in that case. But here there is no such steps happen. So I'll just remove this part. Right. So it stops up to this position, this one only. So it gives the formation of this beta hydroxy ester. In aldol reaction also it gives the aldol beta hydroxy ester, but further it reaction goes to the removal of elimination of water. So it gives the formation alpha beta unsaturated ketone or ester. So in this case also, if we hit the starting, then there is possibility of formation of alpha beta uh, unsaturated ester upon heating. Right. So the option in this case, option so 1, 2. So this is the part come from the acetone and this part from the starting. So option A is the correct option here. Similarly, we have the next question, which is again based on the similar concept. Here we have given only the methyl magnesium chloride, and which again attacks on the we have the ester. So, but if you look at this is the again bulkier group. So we have to think of that one also. But anyway, there is no any such reacting group here. So this negatively charged directly attacks on this group. So this is the CH3, CH2, this O negative, and this is O, CH3 will be remain same. And here, this is the part. And if you look at this group, so this is this intermediate form. So which has the O negative. So this O negative can come back and the elimination of this OCH3 can also take place. So let's draw that one also. CH3, CH2 will be the same part. And here again it forms the keto, and again this OCH3 is since eliminated. So now we get again a keto. And if we have the excess of the starting, so that further react this excess of this excess negatively charged this reagent, the MgCl, which can further react on this compound. So can leads to the formation of this CH2, CH3, this O negative. And I will draw this with the, let me draw fully to here. And then further reaction doesn't take place. So you need to do the workup. H3O plus. So that is the proton, so or acidic workup. So it gives the OH back. And this further the two attacks takes place on this ester since there is no equivalent given. So I just draw up to here. But if they have mentioned one equivalent, then the reaction should stop uh, at uh, at this step only. But I have just added the excess, so this is the product is getting formed. So I will just draw. Option B is the correct option here in this case because there is no equivalent mentioned. So let's consider it as excess or more than two equivalent. Right. So here is the detailed mechanism. You can refer. So the first attack takes place. So this is the first attack. Then the second attack. Sorry, after first attack, this elimination of this entire group. That's the OCH3 group get eliminated. So it forms again the keto. And the second attack further also takes place on this carbonyl. And we get the alcohol. So if we have the ester, it react two times with this Grignard reagent that you need to keep in mind. So there are similar questions, more questions based on the similar approach. I will explain this the another one question which involve the stereochemistry. So this question have these copper lithium. So again, whenever you see the copper, always consider the attack will be takes place or by 1,4 fashion. So we have the one, two, there are two double bonds are present in the starting. So now you need to select between which bond is more reactive. And based on that, there will be the formation of product takes place. So if you consider this one, we have there is a sterically bulky groups on the both sides. So here also there is uh, one group which has the again this entire group, and another side there is here there is will be hydrogen. So if you look at the possible attacks where I'll just categorize into the A and B. So to be easy for understanding. So here this is the A and this is the B. There are two positions are available. Right. So we have the attack can take place either on this or on this. So two options are available. And if you look at the reactivity, so we have here the fourth group is bulkier. So if you look at this entire group, so this entire group is quite bulky, but here the fourth group is the hydrogens. Although other groups are equivalent, so here also hydrogen, here also hydrogen. So there is no any issue with the steric loading on the carbonyl side. But the if you look at the other part of the molecule, so here there is one methyl, that methyl also adjacent to these by one bond with these both will be symmetrical. But the another group here is the entire chain. But on the other side, the another group here is the hydrogens. So the attacks takes place on this position, which is less sterically crowded. So this uh, methyl copper lithium complex attacks on the position A, this is the B, on the A position, not on the B. So that's the this position. So we get an intermediate. So the intermediate will be looks like this. This methyl will be remain same, which is directing the, upward, and the incoming methyl obviously it will takes from the downside, because this methyl will drive the attack, right? So we get this intermediate, and once this intermediate is formed, so what's the other options? So here there is again the double bond here. So either it takes the proton from the after workup, it might take proton, or else there is another possibility. Yeah, it's the simple. It takes the proton after workup and leads to the formation of the keto, alpha beta unsaturated. Here keto, that double bond will remain same. I thought there will be some reactions might be involved with this one, but no any such reaction involved. So once this complex is formed, upon workup, it gives the formation of, so which product? So option B, this product. And the reactivity of this methyl will be comes from the downside, as I have shown here, because of this driving force from this methyl, the steric crowd. So you can note down mechanism from this slide. The option here, which option is here? Right, the option B is the correct option here among these others. Here they have shown that's the wrong. Here, here they have shown direct attack, but because of the copper, this attack not possible. And here they have shown how they change the stereochemistry from the product, but that's not the case. Right. So this was the problems for today. So I hope I have covered some problems which is similar to the assignment questions. There are several other problems, but I don't think I really need to go into the detail, because of this the similar problem that I already covered. The first problem probably the same in the same manner. So here this butyl lithium attracts the proton. It gives the formation of this NO2. Here there will be a negatively charged, and once this negative charge from it react with the C double bond O, sorry, the carbonyl CO2, which is the source of carbon electrophile. So it gives the formation of C double bond O, and this will be the O negative. And upon workup, it gives the formation of. But here, yeah. So this is the no any right. So yeah, the option B is the correct option here. So this was this, I think the same problem that also I have covered earlier. Right. This was the, not this. Yeah, this was the problem with the secondary butyl lithium. Right. So this was the some of the problems, and you can refer the mechanism for this reaction here that given in clear manner. So this forms the lithiated complex, which further attacks on the CO2 and gives the formation of the C double bond OLI complex, which upon the workup gives the formation of the carbonyl acid nitro at the ortho position to this nitro group. There is another one problem. I just quickly show that one. So you have given the methyl lithium and the methyl iodide. So and we have the olefin, sorry, the alkyne CH3. I will just elaborate the structure: CH2, C triple bond CH. If you look at the structure, so this CH bond is the more active one and susceptible to the any sort of base, right? So you get the negative and Li positive. So you get this compound, and when it react with the copper iodide, sorry, methyl iodide, it gives the formation of CH3, CH2, C triple bond C, and this the methyl from the methyl iodide. So I will draw it with the CH3. Right. So this is the product forms after the first and second step. Now you have given the H2PDC and calcium carbonate. So this H2PDC, when it react to the H2PDC, that's the reduction. So that step I will show on the here the later I will show you the another color, right? So we have given you have the starting. So this is the starting right now, right? This is the, let's say, the A. So I will just draw that A structure here. C triple bond C CH3, and always keep in mind this H2PD attack takes place always this palladium. So in this fashion, so the C side attack always takes place. That's the reason you get the C, right? So this product and these hydrogens comes from this H2PDC, the H2 gas, and the palladium in base of the palladium complex and the base. So this is the product we get. So here stereochemistry also you need to keep in mind. This is the we call it as a scene. The attack takes place on the same side. So you get the stereochemistry of this product. So that's the wrong option. So this again incorrect. Right now you need to distinguish between these two. Here you can see the protons is on the opposite side, but here the proton is on the same side. So option A is the correct option here. So for detailed mechanism, you can refer this slide. So it's the same that I have shown, but here just draw with the lithiation methyl iodide attack to get the C triple bond C with the methyl from comes from the methyl iodide. Now on the H2PDC, the attacks hydrogens will be on the same side, and we get the product. So option A is the correct option here. So this was the some of the problems that I like to show from the similar to the assignment questions. So I hope you're able to solve all the assignment problems. So if you don't have any doubt, we'll stop here for today, and we'll continue the session on the next Tuesday. No any already covered, you mentioned, right, that already covered in the. So I hope you don't have any doubt. So if you have any doubt, please let me know. I will wait here for 5 minutes, and we'll stop here for today. So please let me know if you have any doubt.